Question number 1 asks me to determine what kind of graph we have here. Notice I have a positive 6x squared and a positive 6y squared, and they're being added, which normally would make me think this is an ellipse equation. However, because we've got a leading coefficient of 6 in front of both of these, if I divided the entire equation by 6, I'd really just have an x squared and a y squared term that are both positive. So as a result, this is a circle equation. Okay, number 2. Notice we only have one squared term, so pretty straightforward. That ends up being a parabola. It's going to be a sideways parabola. Number 3, we have a 4x squared term, and if I bring the y squared term over here, we would end up with a 4x squared, and we'd have a minus 6y squared. And since we're subtracting the squared terms here, this one would end up being a hyperbola. Okay, if we were adding the squared terms here and we had different coefficients, of course, it would be an ellipse. All right, moving on to number 4. Determine the center and radius. I need to complete the square here, so I'm going to move my x terms together. So I've got x squared plus 2x, and I'll leave a little bit of space there, and I've got a y squared minus 6y. And I'm going to move the 7 to the other side of the equation, so it's equal to negative 7. So if I complete the square here, divide by 2 and then square, I get a plus 1. Don't forget to balance by adding 1 on the other side of the equation. And then here I divide by 2 and square, and that's going to be a plus 9, and I balance with a plus 9 over here. So if I factor this, that's going to be the quantity x plus 1 squared. If I factor the next trinomial, I'm going to get quantity y minus 3 squared. And then if we simplify the other side here, we've got 3. Okay, so the center, this is going to be shifted 1 to the left, and it's going to be shifted 3 up. So negative 1 comma 3 would be the center. Remember, the circle equation is equal to the radius squared. So if r squared is 3, that means the radius is going to be the square root of 3. All right. Moving on to the next question here. Number 5. In standard form, write the equation of a circle with center at 4, negative 3, tangent to the x-axis. So if we draw this 1, 2, 3, 4 units, and then we're going to go down 3. The key here is we need to know what the radius would be. If it's going to be tangent to the x-axis, means it's going to touch it in one spot, and that's going to give me a radius of 3. Okay, and of course the center is going to be at 4, negative 3. So that would be an x minus 4 quantity squared plus a quantity y plus 3 quantity squared. Remember, it's going to equal the radius squared, so it's going to end up equaling 9. And that's all I've got going on there. All right. Okay, moving on to the next page here. Number 6 asks me to graph this ellipse, give the eccentricity and the coordinates of foci. So you take a look here, the center is going to be at 2, negative 3. So I'll go to 2, negative 3. 1, 2, 3. Okay. In the x direction, that's going to be my b value squared. So my b value is going to be 4, and I'm going to go out 4 in either direction. In the x direction, 1, 2, 3, 4, and 1, 2, 3, 4. All right, and my a value is my larger value. That's going to be a squared there, so a is going to be 5, and that's in the y direction. So I'm going to go up 5, and I'm going to go down 5. 1, 2, 3, 4, 5, and I'm going to go down 5. 1, 2, 3, 4, 5, and my ellipse would look something kind of like this. All right. Other things we need to do here. The foci. Remember that for the ellipse, you have that almost Pythagorean theorem, but not quite. It's a squared minus b squared is equal to c squared. You can flip the sign on there. And in this particular case, a squared is my bigger value, b squared is my smaller value. So that's going to be 25 minus 16 is equal to c squared. That's going to mean that c squared is equal to 9, and so c is going to be 3. Okay, so my focus will go up 3 and down 3 from the center, and you've got a graph, this will really help. So if I go up 3, that's going to be the point 2 comma 0. If I go down 3, 1, 2, 3, I think that's going to be 2, negative 6. So 0, sorry, not 0, 2 comma 0. It's going to be one focus, and 2, negative 6, I believe, would be the other focus. And the eccentricity, remember, is always c over a. So my c value here was 3, and my a value was 5. So 3/5 is the eccentricity for this problem. All right. Next one, graph the hyperbola, give the eccentricity and coordinates of the foci. So same kind of thing. Let's deal with this first of all. Remember, for a hyperbola, you do use the regular Pythagorean theorem equation. Okay. So in this particular case, let's see, a squared, a is going to be paired with whatever your positive value is. So a squared is going to be 4, b squared is going to be 9. So c squared is equal to 13. That means that c is going to be radical 13. All right. My hyperbola is going to be centered at negative 4, negative 3. So back 4, down 3. That's going to be my center. So my a value is going to be 2, so I'm going to go 2 to the left and 2 to the right, since this is paired with the x here. Okay, and then in the y direction, I'm going to go up and down 3. Okay, remember, you make a little box here, and you use that box to figure out where the asymptotes are going to be. So the asymptotes are going to pass through like this. And again, they're not part of the actual graph, so you just kind of dot those in. Remember, if it's a positive x squared term, it's going to be a horizontal graph. If it's a positive y squared term, you're going to have a vertical graph. So my vertex is going to be right here and kind of go like this, and like that. It's going to follow those lines, and then the same thing over on the other side. So my hyperbola would look something kind of like that. All right, back to the eccentricity. Eccentricity is c over a. My c value here was radical 13. My a value is just basically how far I'm going in either direction. So my a value is going to be 2. So radical 13 over 2 is going to be my eccentricity. Let's see, so c over a. Yeah, that should be right. Okay. And then the foci, of course, you're going, in this case, you're going from this center point, you're going over radical 13 and back radical 13. So remember, that center point was negative 4 is my x coordinate. We're either going to add or subtract radical 13 to that. And then the y coordinate is just going to stay negative 3. So those would be my coordinates of my foci. So we've got that there. All right. Moving on. Give the, basically I want to write the standard form of this ellipse equation. Remember, your equation needs to be equal to 1. So if we divide everything by 784, we should be able to get the equation equal to 1. Sorry, I'm dividing by 784 over there. And anyway, if you do that, if you divide out 49, you're going to end up with x squared over 16. If you divide the top and bottom by 16 here, you're going to get y squared over 49, and then the whole equation is going to equal 1. So, of course, it's going to be centered at the origin. Length of the major axis, okay? Well, my a squared value is going to be right here. That means a is going to be 7. Remember, 7 is the direction that you go up and down. So the major axis is going to be twice that a value, which is just going to end up being 14. All right. The coordinates of the foci, again, it's an ellipse. And for an ellipse, a squared minus b squared is equal to c squared. So a squared is going to be 49, b squared is going to be 16. If we subtract those, you get 33. So c is going to be radical 33. So from the center, we're going to go basically up and down, because the a value here is going to be paired with the y, so it's going to be vertical. So from the origin, we're going to go over 0, and we're going to either go up radical 33 or back radical 33. And so those would be my coordinates of my foci. I think that should be correct. Yes. And then I need the eccentricity. Eccentricity is c over a. So my c value is radical 33, and again my a value here is going to be 7, so radical 33 over 7, all right? And anyway, it's part D, didn't put it with part D, but anyway, you get the idea. All right, and the final question here is a parabola. First of all, remember parabolas always have an eccentricity of 1, so nothing to calculate there. The center of this, or the vertex, I suppose in this case, is going to be at -3, +2. So I might want to start out by plotting that. -3, +2. And remember that that coefficient out in front is 4p. Okay, so that means p is going to be -2, which, by the way, means this is going to open to the left because you've got a negative multiplier out there in front. So you're going to go back 2 to find your focus, and you're going to go 2 in this direction to find your directrix. So the directrix is going to be at x equals -1. The focus will be at 1, 2, 3, 4, 5. Looks like it's going to be -5, 2 for the focus. And it's funny, it never says to graph, but I think I'm supposed to graph. Remember, the lattice rectum length is going to be the absolute value of 4p. So my vertex is right here. 4p is the absolute value of that is 8. So you're going to go basically out 4, 1, 2, 3, 4 from the directrix, from the focus. And you're going to go 4 in this direction. 1, 2, 3, 4. So here's my vertex. My parabola is going to go through that point there, and it's going to go through that point there. So remember, that distance is called the lattice rectum. It's the distance between, basically the width passing through the focus is going to be 4p. And again, 4p has a length of 8 in this particular case, so that's how wide that function is going to be. So anyway, that finishes the quiz.